Nuclear reactions. We know that radioactive nuclei can spontaneously change into nuclei of other elements in a process called transmutation. But scientists wonder if the reverse was possible. Could a particle, such as a proton or neutron, be added to a nucleus to change it into another element? The answer is yes, and this process is called a nuclear reaction. In 1919, Ernest Rutherford produced the first nuclear reaction by bombarding 14 nitrogen with alpha particles. The result was an artificial transmutation of a nitrogen isotope into an oxygen isotope, and here is the equation. So when you look into this equation, you can tell that the conservation of mass number and conservation of atomic number holds in nuclear reactions just like in nuclear decay. So when you count the total number of mass numbers, here it's 14 plus 4, that would be 28, 18, and here it's 17 plus 1, that would be 18. Okay, so that's for the mass numbers, which is conserved here. And when you calculate the total number of atomic numbers, it's 9 on the left side, and 8 plus 1 equals 9 on the right side. Okay. Okay, I want you guys to also practice the examples here. Okay, Rutherford's discovery of the transmutation of 14 nitrogen into 17 oxygen was actually an accident, but the implications of this discovery were enormous. One element could now be changed into another completely different element. Okay, so the scientists were thinking whether they can convert one element, a cheap element, into something that is like really expensive element. So they tried to bombard a proton with mercury with proton. So this is mercury, and then they actually were able to get gold. Gold is like really expensive, right? Unfortunately, the above process to make gold is very, very expensive. It's actually more than 10 million per ounce.